It's important you do this in a new folder, okay? Just create a Docker file with the file we're going to insert. Yes? Yeah? We run from Alpine image, and then we can say copy greeting.txt, and then we just say dot. Okay, so we're copying greeting.txt into the current location, which we will build in a minute inside the new image. Okay? Yeah? Happy with that? Have you got that? If you need that? Let me recap. You need to be in a new directory, a new folder. Make a new folder. Mukdir. You need to do it with the terminal. Mukdir as a friend. Okay? The file that we're creating in the image, and the Docker file, which is going to be the one we run. Sorry, the one we build from in a minute. Okay? It simply contains those two lines. Okay? Yeah? So then we save that, we come back to the terminal here, do a quick ls to make sure we've got the two files, and then we can say docker build minus tag. Now we have to give this a new name. The image we're building from is Alpine, but we're creating a new image, so let's call this KGISL. And then we have to say, if memory serves, dot. Okay, and apparently it works. So what did we do? What was the command here? So we didn't do a Docker run, we did a Docker build. Yeah, minus tag means the name of the image that we created is this, and we're telling it to look for the file called Docker file with a capital D in the current directory. Okay? And it will then try and follow your instructions. In other words, it will try and execute each of the lines in the Docker file. There's only two lines in our Docker file. You can make all kinds of typos here. It's a mini language, just like any language in computing. But we didn't make a mistake. We could have mistyped greeting here, yeah, and then it wouldn't have worked. Let's just see what kind of error you get from that. Yeah. If I made a mistake in my Docker file, and I put greeting xxx, there is no file called greeting xxx. So if I try and rerun the command, it says copy failed. Okay? So everything has to work. It's just like programming in that sense. Okay? But if we get it right, then it works. And the last line says the tag worked. Okay? Which means we now have an image called KGISL. Don't worry too much about the latest. Okay? Yeah? Yeah, so who's got that? Who's created the image okay so far? Anyone? You don't need a hand? Yeah, you're trying it out. I think we should do it now. This is why we're here, to try this stuff, okay? Yeah? How many of you got it? What do you want to do? Where are you? Okay, so now you're back in your place. Okay, so I'll do an LS there. What have we got there? Okay, so let's make a directory. We don't want to do anything there. So look the. Okay, so cd new. LS dash, you convince me. LS. Okay, so now touch space doc file. No, okay, so you have to move that. You've now got two files. Now, let's be clear. You want to remove the one with a capital F, otherwise things might go wrong. Cool. Okay. Now, echo. Hello. Right. That's it. No, just one. That's fine. Okay. Yeah, that's fine. And then name of the file, some file groups.txt, whatever you like. Yeah. Okay, now we have to edit the doc file. So we've got an editor, can you see it? Whatever, it doesn't matter, something that you can see as part of the doc file in that location. That's the one, yeah, doc file with capital D, perfect. So there we need the doc file command to start. So from capital from, plus two caps from. And then outline, lowercase outline. So what we're building from, colon. We've got it. The next one says copy, capital again. All caps. First one, do with space. And then the file we like to copy. That's it. Space, block. That's it. So that's that. Capital terminal. So now we can actually try the build command, which you can see on the screen.
Okay.
Choose a name now. You don't have to pick the same as I showed you. Choose any name you like that. Choose your name if you like. Success. Okay. So you have an image called biology, which apparently, if everything works, has a copy of greetings.txt inside it. We haven't proved that yet, but we're about to. Okay? So how are we doing here? Do we have the doc on the machine set on? Yeah. This one. So here, what do we want? Shell. So it's like a window shell. One thing that we did here was this Docker toolbox, or is it Docker window toolbox? So we actually got Docker here. Doesn't look like the terminal's name. Okay? Tool name. Yes, we do. Okay, so let's do an LS. Just like that. Interesting. Okay, so what I suggest you do is make a directory onto the side. We'll just make it up, pull it down. Okay, you got 10? And then we go into 10. Yeah, and in here, yeah, what do we have more doing now? This is the integer. We do an extra. Yes, can do it. No. Okay, that's not wrong. Wrong. Yes, now you need an editor open, edit the doc file. What's called the doc file there? You need an editor to edit that file, yes? Yeah. Okay. Yeah. That's the doc file. This is the doc. Second line, copy. Space doc. You have to say where you're going to. Yeah. That's it. No, you're correct. You have to be back where Doc is installed to run a Docker command. Yeah. Which you did. I mean, you didn't run a Docker command. It just said it can't find it. Something went wrong. So let's try that. Okay, now we need to well, that's okay. We did that. We have one place. That's the problem. You need to remove the TXT extension. It just has to be moved off the file. Enemy. Enemy. Capital D tab. capital D, just type capital D, and then the tab character, I don't know if it's sort of appreciated. Yeah, yes. So that's the file we're copying from. Copy to that. We want to learn the techniques to avoid typing. So now we should have just a file. Let's have a look at the file. Doc.test.txt lowercase. Test, lowercase, test. It looks like, and then we go back to our doc command. It says, all files directed out to the will have just okay, so this is Max into obviously I can stuff Max. But now, yeah, we've got the initial. Yeah, yeah. Yes, you didn't make the right file. Again, there's lots of techniques to go wrong. You have to make a file called Docker file. It's a Docker file with a capital D. Okay, that's it. Save it there. Now go back to the terminal. Do an ls there. Okay, cool, let's do it there. Wherever it was. That's there. Still not right. No TXT yet. This is Windows 3. Okay. You can't do it there. It's difficult to do that. Back to MB. Move to the Linux command. Do capital D. The tab character. And then space. And then capital D. Space. Tab character. Sorry. Oh, sorry. That's it back. Complete it. Tab character. Complete it. Okay. That's very interesting. Then you can do this is the sheet again. Docker text, Docker file. Okay, that's getting worse. Okay, let's try again. You're always going to have something. Just need to we'll have a file called Docker file, right? Docker file. Let's try this now. So now we actually have a file called Docker file. Cool. Let's see what's inside it. From 7, copy hello.txt space. There is a file called hello.txt space. This is looking good. So now, somewhere we're going to build command. This is looking good. And you get it's work. You get a warning, but it's work. Cool. Yeah. You want to open it from the end. You need to enter, yeah? Any edit will do. Yeah, just edit the file. Well, you want to know what? Typically, you can only know there's no file extension on Docker file, which is confusing. Yeah. What are you in there? Are you in text edit? You are. You're in text edit. Okay, my apologies. I didn't see that. So, yes. So now we're good to go. It's got the right name. We need to do from, capital from. Capital, all caps from. Sorry, actually. All caps. The first word is always all caps. Yes. That's it. Outline. Lowercase now. Lowercase now. It's just the first word that's always okay. That's it. Go along. 2.7. And copy it in uppercase. Lowercase copy. First word is always lowercase. Space. And then what's the name of the file you made? Yeah, just EA. So, yeah, that's fine. So just type whatever the name is, you're getting shows right there. Space no space again, and then dot. Dot, single dot. That's it, and just save that file. Okay. The rest, no, that's the cat dot file. CAT. Dot file. Yeah, you return this. This looks, you say the project looks like we've got. So we're looking good. So now we can try the building block. Tried that yet? Yeah, that's it up there. Yeah. Oh, but hang on. No, don't do it yet. Where are we? There. What have we got in that direction? Oh, no. That's not it. So, you need to do this off the side. It's only a second, not a second. If I make the direction here, move the copy file. It's natural. Okay, so this looks good. A file called doc file with the correct name. The purple rating, that looks good. You're going to empty folder, this looks good. Let's have a look at the doc file. And the doc file, that would be empty file. The doc file has 7 characters in it, so this is something you need to edit it, yes? Which editor do you use here? You simply need an editor. Which editor do you normally use? Don't have? It's not what you use. You need some kind of editor here. But it must be one that yeah, that'll do. Okay, you have to look at that. Here it is. Let's open the file. Hopefully we're in 10, yeah? Users. You'll see yes, you'll see okay. There we are. Users. Connection. You said it did 10, yes, 10, okay. 10. There it is. That's for completing. Okay. So. I'm still showing you the TXT, of course. The doc file is correct, so that's fine. We can use that. We just have to look at the file, doc file. But it doesn't see that. That's very strange. Why does it not see the file? Now we have Docker file without extension, root.txt. Our editor, we have the Docker file, which we save. So at the moment, it will say from, but that's it. Excellent. So now let's finish this off. So we're going from outline in lowercase, word outline. I'll type it right there, outline. And editing a new file, you're typing right where the cursor is already outline, A-L-P-I-N. That's it, yeah. With an E on the end. Yeah, then a colon. Then a colon. A colon, I'm sure that will. Cool. 3.7. That's it. Excellent. And now we need a new line. So now we do copy in all uppercase. The word copy, C-O-P-Y, all uppercase. All uppercase. Yeah. That's it. That's it. Save the file. Good. Now back to the second one. This is here. That's it. Now here you can type that command. Docker build command. Yeah, the very first line. That's it. Oh, it's lost it. What's your in charge of time? That's absolutely fine. Yeah. We're going to try and get a little bit afterwards? Yeah.
You guys want to break?
Yes. What's not? You're inside, I think you're inside the container. The previous command is Docker run, right? Okay. That's what you need. Let's come out of this container. Now we're back to where you're working on your laptop, right? And we're doing your, looks like image now. When did you create your file? You made two files? Didn't you want to Docker file? Or did you accidentally do that inside a container? I don't know. Where were you here doing this? You were also in this end. The doctor and the container. It's the name correctly in the container. Exactly. Put into that directory. It doesn't matter what you put correctly. Put in the doctor container already. So we lost it. We do this here. Okay. Let's make a directory. Okay. Yeah. Oh, thanks. We are. But the problem is you're inside the container already. No, we need to do this here. Okay. So, which version of Docker is it? And yet, we haven't got MD. This is not right. We're in there. What's going on? Yes.
Okay, yeah.
We're in the wrong place. Forget what I'm doing. This looks better. Yeah, now we're getting something. Okay, so now we can make the direction. What do we say? T. Right. Now we can echo into greeting. Yes. Now we can make .file. So it works. Now you can edit the document file with what we said. Run the document and it'll work. Okay? Yeah, it's tricky this stuff. When you first think of doing it, you think, where am I? Sometimes you're here, sometimes you're in the container, right? Sometimes you're here in the container. Yes. Okay, that's the beginning. Cool. Glad you enjoyed it. Okay, thanks a lot. Thanks for coming. Now, if you want, you can run that. It's not in this song. So no, we did maybe then we did that outside the team, that's the problem. My mistake. So we have got team, so cd.doc. And I should go to md.bar. Should see it there. And there we go, into the team. One of the file yesterday, yes, meetings at TXT, so hit present that, and then MD meeting. Save it in a CVT. So now that's there. Now try the just open up our phone. Oh, you want to practice school one? I love it. That's great. Yes. You've done it. Yes. Okay. I wasn't going to say anything. Okay, so we're back. And hopefully you can remember what we did before the break. We've got a separate directory. It's important that you make a separate directory to do this stuff. Yeah? And inside that directory, we have a Docker file and just a plain text file. Yeah? And the plain text file contains our greeting. This just says hello. You all might say something different, okay? And the Docker file made a new image.
What you guys are doing?
Yeah. In this Docker file, which is Docker file with a capital D and without .txt at the end, that kind of thing catches a lot of people out. We're specifying the commands which are run one after the other, and together they constitute the commands we're giving to Docker build to build a new image. The only thing you can do with a Docker file with a capital D is use it to build a new image by saying Docker build, the name of the image you want to build with the tag, and then the directory that contains the Docker file. That's why we put the dot. The dot means the current directory. Okay? And you say what you'd like to base your image on. Could be Ubuntu, could be Alpine. It's entirely up to you. Okay, you have certain requirements that you need a certain operating system at some time. We're picking a small one for the reasons we said, and then you can do whatever you like using the commands that are available to you in the Docker file. And the first command, first word of every line, of every command inside Docker file always has uppercase. So from is in uppercase, copy is in uppercase. Every command you can use has to be uppercase. Now, if I come back to my prompt here, and I just make sure to rebuild my image. So there I've rebuilt my image. What would happen if I run this image? What did we call it? What did I call it? Forget now, KGISL. The answer is nothing. Because I haven't set it up yet to do anything. Yeah? That's not to say that it doesn't actually have something in it, of course. Yeah. If I add the minus IT, which means interactive plus teletype, if you're picky, and I say I'd like, and now you add at the end sh. You're saying, and when you start your new container that you're running, yeah, I'd like you to start using sh. A shell starts, and you'll be in that shell. That's why when you do it this way, it doesn't immediately return. On the previous line here, it immediately returned because we hadn't told it to do anything, and there was no default. This time we're saying, this is what I'd like you to do inside the container. So this slash here means we're inside the shell. And now we can do whatever we like inside the shell. And we did earlier on do an ls to convince ourselves that the copy from the Docker file had worked. And there it is again, greeting.txt. That's nothing to do with greeting.txt on my directory. This is a copy of that file I've copied into the image. Yes? So I can exit back out, and now I'm back to my location. Yeah, there's the files again. So let's prove this. If I edit my greeting and I say hello from KGISL there, and I come back to here, and then I rerun this command, yeah, then once again I do an ls, greeting.txt is there, and I just make greeting.txt look like that, look like that, changed it very slightly, just I said hello a minute ago. What does it say now? Anyone think, what's it going to say now?
Hello.
Just hello. Doesn't say hello from KGISL. Why not?
Because we haven't built.
We haven't rebuilt. Yeah? When you do a build, it does a build. What did the build say? Whatever you told it to say. What did the second line say? Copy. So when we ran the build, the Docker build command, that was the moment that it took a copy of the file and put it in the image. And that image is now baked. It's got its own copy of the files. You change the copy over here, the original, that's fine, it's not having no effect on the copy that's still in the image. Yes? So if you want to make the change that we've made in the original actually appear in the image as well, you have to rebuild the image. The image is a completely isolated, separate snapshot of all the files. That's the point, right? Okay? So you can do that. You can do that's fine. You just change the file. In this case, it's just a file. But obviously, in the context of software development, this would be some kind of source file that's telling running some program or something. And every time we wanted to build an image that contained these source files, you can't just edit the files. You have to rebuild the image. So we rebuild the image. Let's put it to the top so you can see it a bit better. Should be up here somewhere. I keep going. Oh no, because it's in history, of course. KGISL on the current directory. I'm still in the Now it should be there. That's the shell one, the run, don't want that. That's the run one, I don't want that. That's the build, that's the one I want. So there's step 2 of 2. That's the copy going through its stuff again. The image we created was still called KGISL. So now if I do a Docker run here, I'm back in the shell, I do an ls, make my shell in the container, there's greeting, and if I look at greeting now, what will it contain?
Hello, computer.
Yeah, that's what it contains, okay? Now just as another thing to learn, we'll just go through things and see what we can do in the time we've got. You can do the sh, which if you just leave it like that, takes you to an interactive shell. But if you do that, you must remember to put the IT. Minus IT is what now enables it to be interactive, as you saw me doing it, okay? That's a very common kind of thing to do. But if you want to just run one command, if you want to do one command, you might do sh, you go in, you wait for it, and then you do pwd, you do something. Or what else can we do here? We do cat file. Let's look at it. Cat issue. See what it says. It says we're in Alpine Linux, lovely jubbly. And then you do an exit. Well, that's a lot of effort for a small amount of return. You can just go sh minus c, and then put the command directly like this. Yeah? Now quite a lot of stuff's happening because we're still spinning up a container because it's Docker run. Yeah? The name of the image we're building it from is KGISL, same as before. When it starts a shell, but rather than the shell being interactive, so I don't actually need that anymore, I'm immediately giving it the command that I'd like it to run, which it did, okay, and then it finishes. Yeah? So that's, again, a very common thing to do. But even more common is to do this. If we go back to the Docker file, we can learn a new command. And the command is called command. So here if I write cat, comma, greeting.txt, yeah? I have to get the syntax absolutely right, which is always the case with software, yeah? So command has to be uppercase, CMD. I've got two double quoted strings here, comma separated, and they're inside square brackets, yeah? And this is really a similar alternative syntax kind of what we just saw. Yeah? This now becomes the default command that runs when someone spins up a container from the image that will get built from this Docker file, yes? If you don't say differently. You can still override it if you want with an sh command. So let's see this. So if I come back and rebuild the image, I must rebuild the image. The image is rebuilt. Yeah? And now I do a Docker run without any extra commands, no sh, which is before we did that, nothing happened. The container came up, nothing happened, and the container went away, nothing happened, okay? But now, it does what we told it to do. Yeah? So this, as it stands now, basically this is the core of what you need to know for Docker, for making your own images. Yeah? You have to start from an existing image, obviously. You can choose. Yeah? We'll talk about that in a minute. You have to do the stuff that's specific to you. And at the moment we're only doing a copy. But typically what you'll also do is a run. Maybe we'll get to that later. Okay? But you have to, if you think about it, what you have to do in the bit between the from and the command is all the things you'd have to do if you were actually setting up an environment that's actually on your machine. Right? So, for example, I was making a little application yesterday, and if I was at the terminal, let's bring up a new one. If I was literally at the terminal, having to build this application, which was a Node application, it's a JavaScript Node application with Express as its web server, then I use the npm package manager to install all the dependencies that I have for my particular application, okay? And then once that works, I can write npm start. And again, as long as my package.json file is correct, I've now actually issued the correct commands in the Node package manager, npm, the Node package manager, to build all the things I need to run my application in Node. Yes? And that's had quite a large impact on my local hard disk. I've now got a whole bunch of Node modules that have been installed right here. Okay? But it worked. I did it yesterday and it worked. Yes? But I don't want to have to keep doing that over and over again. So, all I need to do, don't need to save that, yeah, is start to do them here. So let's just copy that one out for a minute. We can imagine what it looks like. I would say run npm install, run npm start, and here I would have a copy of basically everything, all of my source, yes? Except this isn't quite right because npm start would go in the command, of course. Yeah, that's what it would actually look like because that's the command to actually start the server. Yeah? This is how you install, you set up your application, yeah, in Node, and this is how you then run it. That's exactly what I did. That's pretty much all I had to do, except there would be a problem if this was all I had to do. Can anyone see the one thing that's missing? I mean, there's obviously, when imagining there's only one command line, that's gone away, okay? This, in case you're not familiar with it, in Unix, a script file that starts with a hash is a comment. So in Java, we saw double slash, and it was a comment, that meant a comment. If you're in a Linux script file and a line starts with a hash, this character here, the hash, that means it's a comment. Okay, so let's just move those out of the way for a minute. Yeah? Anyone see what the problem is if I was running that line, line 4? What's the problem with line 4? Let's think about it. Let's come back to it in a second, because it's a little bit tricky until we figure it out. Let's go back into our KGISL command image and create a container from that, spin it up with run, and bring up a shell. Now I'm in the shell, and I do an ls. The same as before, there's the greeting, yeah? And now I do cat greeting.txt, and it worked. Why did cat work? Cat worked because there's something called cat already installed. Where is cat already installed? Okay, well, there's only two possibilities. Inside the image that you're running inside, the container, sorry, that you're running inside, there's only two possibilities. Either the program that you're running, cat in this case, was in your base image that you came from, or you copied it in. Right? Those are the only two possibilities. Yeah? In this case, it came from the base image. Yeah? No worries, that's the way it works. But if I try and do an npm here, is it going to work? It's not there. It says, what the hell? There's nothing called npm here. There's an npm where I came from on my local machine. I'm not on my local machine. Forget it, that's gone. Isolation, right? You're in a container. All you've got is all you've got. Okay? And all you've got is what you decide to put in it, which in our case is almost nothing. Okay? Because this was our Docker file. We deliberately went for one of the smallest possible base images. It's got cat, okay? It certainly doesn't have npm or node. Doesn't even have node come to that, or express, okay? But the basic problem is it doesn't have node or npm. If it had node and npm, the npm install would work. The copy dot here dot, that would bring the package JSON file in, and the npm install would install express, which would be one of the dependencies. But that gets all a bit convoluted. The point is, that line isn't going to work. For Docker build, to make that line work, you would have to do literally what you just saw me do. Bring up the container, try npm, and it wouldn't work. There is no npm at that point. Right? So how can we install npm? We only have two choices. It's the same. Ultimately, this stuff is pretty simple, okay? There's only two choices. First choice is you do some command here, whoops, you do some command here of some description to get npm. So you're in the Linux box, you might try apt get install npm or something like that. In this case, that won't work because apt get is for Ubuntu. We're not in Ubuntu, we're in Alpine, not going to work. But the basic idea is sound, okay? You have to do apk. So the first option is you just install it. You install it as if a normal, the command you would actually run if you were actually installing it on your local machine, right? What's the second alternative?
Install outside the Alpine and move it to.
There's only two choices. We just exhausted the first choice, yeah? We somehow install it because it's not there already. The second choice is we change the base image to something that has it. That's all it is, okay? Those are your only choices, right? So is there a base image that has node on it? It's a good bet, yeah? It's a pretty good bet. Node, wonder what the version might be, 8 perhaps? Okay, let's try it. Well, no, let's not try it. It's probably going to be quite big. I imagine it's quite big. It's interesting. Can we find out without actually downloading it? Or have I got it already? Maybe I've got it already. Let's have a quick look again. So I'm not in the container. So I do a Docker PS. I'm there. So in Docker images, grep node. Yes, I have node. And it's 8. Fantastic. Okay. So let's get rid of all of this stuff here. And we'll just make a new image. You just have to watch me do this one because I don't really think you want to install. You don't want to download the node base image, okay? But there we go. That's the entirety of my Docker file. It's only got one command in it, which is from node. From node. That's fine. You can do that. It's kind of unusual. Normally you have something afterwards, but it's a good starting point. Other than that, it's the same. I come back to my prompt, okay? I make sure I'm in the right directory so I can see the Docker file. The Docker file is there. I just have a look at it to make sure it's the one with node at the top. Let's make it really nice and clean by getting rid of all this stuff. Okay, so there's just that, okay? So now I do Docker build ---- tag, and I'll call this fake node. And that's the current directory. Okay, and there we go. It's done its stuff. It didn't have to pull that image, which was good, because we wouldn't have had time, okay, probably. It already existed, and so now I've got a new image called fake node, which is based on node. Like I said, normally you add some extra files in there, which is your application. In this time, we're not adding any new files. We've only got what node's got. So let's see what we've got. Let's actually bring up a container. So it's called fake node. So we do docker run -it fake node, open up a shell. We're in the shell, we do an ls. Okay, can we go npm? Of course we can. Right? That's why we picked. Because node has npm in it already. What version of node have we got? Forgotten already. 8. We chose 8, so it's a good bet we should have 8. In case you can't see that, I'm going to try node here minus version. I'm in 8.11.3. Okay, someone built an image for node version 8, and we're in it. Well, now we're out of it. Okay, and so now I can actually run npm. I can start to try and do what I normally do, npm install. Okay, and npm will work, but this now I can say there's nothing to install. Right? Because I haven't put any files in there yet, because I'm missing the bit in between, which would normally be copying your application into the image, ready for it to be installed. Yes? So let's see that fail. So if we try and build from that, yeah. It says, there we go, it says can't find package.json. Package.json is what you need to build a node application. Well, interestingly, that was only a warning for npm. That's very naughty. That's about that. I'm not going to go into that in any detail right now. Okay. So let's put it back to the way it was. Just for now. Back to Alpine. We're copying from. We're not doing that. We're not doing that. We just have a command to do the cat greeting, which means we need to put that back to what it was. Was it greeting? Yes, greeting.txt. Okay? So we're back on the base image, which is outlined, nothing to do with node. We're copying greeting.txt into the image. It's still there. So it's come in. And then what are we doing is the default command, which is what you get unless you provide an override with the sh-c. The answer is it just outputs the contents of greeting, which is, what is that? It's now hello for KGISL. Okay? So now if I build the image, don't want to call it fake node anymore. I want to go back to KGISL. It's there, and if I run that one, KGISL, don't provide the sh, I get a new message. Yeah? So let's see a real one, just as a quick demo. Let's see a real one, because I've been doing some work with Citibank in Chennai, and I've built a bunch of stuff. And the one we've been doing is just a simple application of the faces of the students, and I built it as a Node application, and so there is the package JSON file. Yes? And that contains the critical dependencies, expresses the name of the web server. Don't have to look any more at that. Here's the Docker file. Yeah, what does it contain? Basically, just what you saw. Yeah? That's all it is. Yeah? From Node 8. Oh, I didn't mean to put that star in there, that's a mistake. I didn't see that. I'll fix that later. Okay, so make sure we get package.json, and that's all we need to do the npm install, because that has the dependencies. Yeah, and after that, get the whole rest of the source. Yeah, and then start a web server on some particular port. Yes? So I can use that to build my image, and then run my image, which is it repos Chennai? Which one was I looking at? The Facebook node. Okay, and here I'm not going to actually manually type in the Docker build commands. That just gets boring. I put the commands to do that inside a script. So all I need is sh, and here's my scripts, so that I don't have to keep retyping them. And what I need in this particular case is the toolbox. Okay, it does a bunch of stuff. Most important of which is what we can hopefully recognize at the top here. What's this? What's all this? I've highlighted. That's the commands in the Docker file being run one at a time. Yeah? We started from Node 8, and you saw that already exists. It doesn't have to pull that image. This is comment. There's a label which is literally just a comment. Okay. We can set the current working directory for the rest of the commands, and then it's what we saw just a moment ago. Copy the critical JSON file, which npm needs. Do the npm install so that it sees the dependencies in that. Okay. Copy the entire rest of the source. Yeah. Set up the default commands so that when you start the image. When you start the container from the image that we're building here, it's going to start the server. So again, you could do most of these commands actually on your local machine. And as long as you have Node installed, it would be fine. You'd be starting a local server. Yeah? You're doing this inside a container. This is happening. This is now not on your local machine. You don't need Node installed on your local machine. Yeah? This is just running some tests. I'm a big fan of testing, so I make sure I run some tests. And now I've got an image which is actually running. And this was a whole pipe that built the image, it ran the tests in the image, and then if it worked, it brought up a container which is on port 80. Yeah? So if I do a Docker PS now, which is perhaps better, there's a modern way of doing this, which is Docker container ls. Yeah, we can see the containers that are up, and one of them, there's one from, I don't know, well, that's from, I accidentally left that one up. There's a different application. The one we're looking at is this one, which is on port 80. Yeah? That's the container that we just brought up just a moment ago. And this is on my machine. Except I'm on a VM because I'm on a MacBook, which doesn't support Linux natively, so I have to do it through the VM. So if I go to the address of my VM on the correct port, it's running. This is the app that I built in Node. Yeah, so here is the faces of the students, current year students, okay? Yeah. Helps me remember their names. I could run that locally if I want to. Yeah, I could run that locally if I want to. I'm not running it locally, I'm running it through a web server, hosted inside a VM, okay? Completely isolated. I wonder if we can do both. Let's see if we can do both. We're here. How does Node work? You should be able to go into app. npm install, I think, is already run. So if we do an npm start, no, we haven't done it. Oh, of course, we haven't done an install. Yes. May take too long. So let's try that. Let's just give it a quick go. npm install. That was pretty quick, actually, of course, because I got so few dependencies. Now I do an npm start. What's happened now? Port. I'm not telling it the port number. How did I do that? Probably set this up in a shell if I remember correctly. I'm in the wrong directory. I'm not going to spend much longer on this. Just wanted to give you a demo if I could have them both running. That's that pipe. Maybe it was just that one. Oh, of course, there's something on 80. There's something on port 80. What is on 80? What is on 80? Facebook is on 80. And I want to be on a different port. So, yes, set it up with the ability to do a different port. So I start on 82, let's say. Interesting. You want an 80? Anyway, I was hoping to show. The same app running both inside a container and not inside a container. This one's inside a container. We can tell because it's coming from the IP address of the VM. And if I'd been able to run one not in a container, it would have simply just been running on localhost. Okay? But that's obviously not the same thing. There's something, so there is something on different 80. That explains why it didn't work on 80. It doesn't explain why it didn't work when I tried to do it on port 82 locally. But anyway, that's a bit of a digression. Whoops. Let's go back to here. Okay, so that was an example. You saw that running. That's now actually running. If I go back to the previous one, yeah, there it is. 192. Let's get rid of that. Get back to where we were. Fix that up later. Okay. Here we go. This is where we were. Yeah. So any questions about anything? Anything you'd like to try yourself now? This is the way to kind of try and learn it. How much time have we got left? 45 minutes. Well, you could do something in 45 minutes. Yeah? Basically, what I'm thinking here is probably don't want to do anything more than just starting from Alpine, but something inside Alpine that would be potentially useful. Yeah. But my virtual machine was already started. Yeah. But that's a good point. When I completely start from scratch my Docker environment on my MacBook, it has to start the VM, which is called default in VirtualBox. And that takes a good minute, probably something about a minute. But once it's there, it's there. Okay? And the containers that you see me running aren't running on my machine. They can't run on my machine. My machine's a macro. They must be on a Linux box. Yeah? But they're actually running on the default, the VM called default, which is a Linux box. I'm kind of double virtual just going on, right? I'm doing it, I have to do this on Linux, I'm doing it in a Linux VM. Okay? The images have inside them the files. Yes. You don't extract them from the image, they go into the image. No different than copying from anything else. Yeah, there's no VM involved. Yeah. It is possible to copy. It's a good question. That's actually a very good question, which has popped up. What does copy do on line 3? Does copy on line 3 take files from your hard disk and put them inside the image, or does it take files that are in the image and put them on your hard disk? It takes them from your hard disk and puts them in the image. They have to exist. You saw when I mistyped the name greeting, and the Docker tried to run the build and get to line 3, and it got to the copy line and says, I can't copy, there's no file called greeting, blah, blah, blah. So copy, and the whole idea of building is taking the files that are on your local momentary copy of your files. You might change them in 5 minutes. What they are now, you're copying them into the image that you're building. And you have to choose the name of that image, obviously. That's what you do with the tag. Docker build tag. Tag is the name of the image you're building. Okay? Yeah? So they're going into the image. What about if you want to get them out of the image? That's possible. Yeah? But you're not quite thinking in the right way yet, because throughout the afternoon we've been talking, fundamentally we've been talking about 2 things. I've been using 2 words more than any other. And those 2 words have been image and container. What's the difference? Not clear, it's worth trying to be clear about this, okay? Snapshot, someone said snapshot, I like that word. Yeah, an image is a snapshot of some files on your disk. That's what you get with a copy, plus some that also get pulled in when you do a run. You might do a run with some kind of install, it's pulling things off the internet. Okay, well that's again not affecting your hard disk. You're not doing an install on your hard disk, you're doing it inside the image that you're trying to build. Okay, now of course you might fail to build the image. There might be the install might work, and then there's a copy, and then there's another run, and then there's another command at the end of the Docker file, and that one falls over. It's a shame you got near, but you didn't actually get a finished image. They all have to finish to actually finish, and you get the image, which has the name of the tag that you supply. Okay, with minus tag, yes? That's what an image is. There's no life in an image. An image is just a static snapshot of what the file system looked like after all of the commands successfully finished. They all have to successfully finish, and if they have successfully finished, you've now got an image with a snapshot of the result of all of those commands running, and the local disk is unaffected. Okay? Now, if you want to later on get some of those files out of that image, you have to first bring the image to life by running a container. Okay, so how do we make a running container from an image? What was the command for that? Docker run. Docker run. So your 2 fundamental commands are Docker build. Docker build. What does that do? It builds an image from a Docker file. Okay, and the second fundamental command is Docker run. What does that do? It spins up a container from an image which you have to have built. Okay? So now we have the possibility of starting the container, and when the container is still running, grabbing some files from it. Alright? That's the way we would do it. Possible. Very possible. Okay? Sorry? To get files out of the running container, you mean? Well, there's a number of ways of doing it. Basically, you can do it with what's called a tar, with a pipe. You can do it with a tar pipe, but the simplest would be to do it with just a pipe. Let's try and do it. Let's try and do it. I have to remind myself of the syntax for this, which is good. So, back to the terminal. Excuse me, I'm in the wrong place. Where do I want to be? Where was I just a minute ago? That was one down, I think. Okay, to that start, yeah. Inside Docker PM, that was it. Okay, so I've got that one. And let's clear the screen, do a Docker build, and this one is tag KGISL, the current location. I want to just get rid of that though. Let's just take away the command for a minute. So let's build that one again. Okay. And now if we do a Docker run KGISL, nothing happens. Why? Oh. Why did something happen at that time? Oh, because I supplied the IT. Yes. Okay. But I didn't get the file. That's the important thing. I didn't get the file. The file is inside there. Let's prove that. So if I do an ls, there's the greeting file. Same as before, no different. So let's exit again. Okay, now we're ready to try. So we need a Docker run, but we need a variation of Docker run. Instead of doing this, instead of doing this, we would do what? Well, sorry. We'd first start the container. Let's just do one thing at a time. So we would have to start this in a detached fashion. And let's make this easy for ourselves by giving this a name. Let's make it the same. Okay, so let's see. So now we have an image, sorry, a container running, which you saw me start 3 seconds ago. Yeah? And up till now, we've only run a container in 2 ways. Up until now, we've only run a container either by adding an SH, and we shell in, and do whatever we do, and then we finish, or we just let it do what is the default command, and it did what it did, and the container didn't hang around at the end. But now, as you saw, I did a detach. So the critical thing here we've done is a detach. Yeah? So now we've got the container running, we can try and get the file out of that container. I think I remember how to do this. Docker CP, see that one? Copy files between a container and the local file system. It's a long time since I've used this particular command, so I'm going to have to get some help. So let's do Docker CP minus help. Hello, Q. Okay, so it looks very simple. It's coming back to me now. Yes. So Docker CP, you can go either way, but you must have a container running already. We've got a container running already. We detached it precisely for that reason. Okay? And we can copy from the container to the local machine, okay? Or we can copy from the local machine into the container. In our case, we want to go from the container to the local machine. So we need to know the name of the container, and we need to know where it lives. Oh, we also have to pick a name for the file as well, obviously. Okay? So we go back and look at rerun it. We do the Docker PS. what was the name of my container. So there's the name of the image. Okay, but here's the name of the container. So in this case, I made it the same. That's fairly common. Okay, so that's one thing to remember. And the other thing we would need to do is know where it lives. Yeah, because you have to see the path. You have to know the path. Okay. So how can we know that? I can't remember it, so I'm just going to momentarily do it. Let's get to the top of the screen again for you. So I'm going to do docker run --rm -it of the image, and I'm going to shell in so that I can do a pwd. I'm at the root directory. So greeting is actually at the root directory. So now I know the path. I have a chance of doing my docker cp. So docker cp from the name of the container, which was the same, and then it was colon, and then it was the path, we started there, and it was greeting.txt. Let's make a deliberate mistake there, just at the start. And let's try, imagine we're going to copy this into a new file called copy of greeting. .txt. So this should fail because I've deliberately provided a name, and that file does not exist inside the container. So let's try it, and there we go. Nice error message. It says no, there's nothing called that. So let's see if we can do it with the actual file. It seems to succeed, but of course the question is, do we have a file called copy of greetings.txt? And we do. But is it the same? We have an ls, well, they're the same number of characters, yeah? 17 bytes, that's all. Let's have a look at the first one. There it is, same as before. Let's have a look at the other one. Cat is what I meant. Yeah, so we've managed to extract one of the files from the container, which is still running. We do a docker PSA, yeah, the detached container is still running, came from kgisl, its name is kgisl, but it's just one container, that's come from kgisl. I could repeat the trick, I could say docker run ---- detach, if I can spell it, kgisl, should be all I need, I think. Oh, I didn't give it a name. That was stupid. Let me just fix that for a minute. Let's just remove this container with the brute force and try that one again. I'll give it a name this time. I'll call it kgisl2. Minus is missing, thank you. Yeah. So Docker run, I'm building a container from an image. What image? That is the last argument. Yeah. You're detaching it, so the container is going to hang around after we finish, so that we can do stuff with it. Okay? Minus name, give it a name so I can see it when I do a docker ps. And after this, there'll be two detached containers, totally isolated from each other. Yeah, each with their own copy of greeting.txt and everything else, absolutely everything else. Okay? And now we do a docker ps -a. There we go. Got two of them. One's been up 6 minutes, this is the new one, it's 3 seconds. Yeah? Just, it really is kind of like VM, it's just much lighter weight. If you use VirtualBox, you know, you sort of see the heavy maintenance and how much effort it takes. Yeah? Imagine these as 2 VMs. That's kind of what we're doing here. Okay? Except it's lightning fast. Yes? So this is not a million miles, again, from what I do in Cyberdojo. Yeah? It really isn't. I promise you, it really isn't. Let's take a step again. Look, what happens when you hit the test button in Cyberdojo? Files come to the server spins up a container, and has to put the files into that container. So you should hopefully see that that means the container pretty much has to be detached, right? The container is detached so that it's ready to receive the files and inject the files in with a tar pipe. Okay, basically you tar up all the files that you want to. You compress all the files into one tar file, like a zip file. If you're familiar with Windows zip files, it's like that. Think of tar and zip as the same. You compress all the files you want into one zip file. You copy that one file in, like with Docker CP, and then you can do a command inside the container to unzip the files. Now you've got all the files inside. Okay? Plus, you're in the right container, because it was a container that was spun up from something that had all the correct commands in its Docker file that has installed Java, in our case Java, okay? And then the final step is just to run cyberdojo.sh, which has the magic commands to actually run the compiler on the source files that you've just injected, okay? It has to be detached for that to happen, plus there has to be a sort of outer wrapper of a 10-second limit. I mentioned that once before. And you don't get an infinite amount of time for your particular tests to run. If you accidentally write an infinite loop, okay, after 10 seconds it will just time out. So there's another little wrapper around the Docker run detach, and it'll kill it after 10 seconds. Most of the time it doesn't need to because it's dead already, okay? Because it finished well before the 10 seconds were up, okay? So it's a tremendously clean technology. It's so fast, and it enables you to do things in an utterly repeatable fashion. Yeah? The isolation is about making things repeatable. If I have some local files on my hard disk, I run a Docker build to build an image, and then I do the same thing with the same files, I'm going to get the same image. Okay? Amazing. Great question. Great question. Any other questions? I think actually there's probably one more command we should learn, just to sort of make a whole. As we've been starting containers, we should really learn how to remove the containers too. Yes? So how do you remove a container? There's two ways you can do it. I'll show you, well, there's three ways you can do it. I'll show you all three ways. Okay, it's very easy. The first way is you can just use the name. If you provided the name, the -- name, when you ran the container, Docker run, you can just use that name. So this is the one that's up, kgisl2. I can simply say docker rm kgisl2. Okay? And now if I do Docker container ls, it's gone. I just got that one. Yes? So that's a nice, easy way. Sometimes, for whatever reason, you might give an individual container an individual name. In that case, it still has an identifier, yeah, which is a shard, like you get with a Git commit. It's just a secure hash algorithm, a shard identifier. So that's another way that you can get rid of the container. Okay, so this one is kgisl. Let's not use the name this time. Let's use this char hash, which starts DC and then 3 4s. So if I do docker rm DC and then 3 4s, this one's a little bit different, I think. Did I do a force? I can't remember what I did now with the previous list. Let's quickly look at my history here. No, I didn't. That's interesting. Not entirely sure what the difference is there, to be honest. But I know how we can get rid of it. We can use a -f option. Okay, so the F means force. Standard Linux command -f nearly always means force. And I'm using the wrong one because I mean, I've already killed the one that was 2. The one that's running is this one, but I don't want that either. Brain fart. I'm trying to remove this one from the shard. So let's come back up to what I'm trying to do. There we go. There it is. Now I put the -f on that one. Okay, and now I've removed that container. Okay? So if I do a docker ps, now I'm just left with a few other things left around. What are these other things that are left around? What is this one? Remember what this is? When we did a Docker run hello world, do you remember that? Yes? So, again, let's clear this. If I write Docker run hello world, yeah? Then what I'm not doing here is providing the --rm. Yeah, so if you don't provide the --rm, when the container, when the command that you're running finishes, the container stays up. Yeah, but if you provide the --rm, then it will come down. Okay, so this is the way that you typically do -c, and here you do one command. Yeah, you just want to do that one command. You want to spin up a container, run the command's finished, and then you want the container to go away. And the --rm clears up after you. Okay? Yeah? So let's make it useful to make a little list of these. These are quite useful. So let's open up a new file there. So this is the first one. What does this one do? I'll make a comment. That one leaves the container up, which would have to be removed later with Docker rm. Yeah, whereas this one here does automatically Docker rm when the command finishes. Yes?
Do we call that as an orphan containers?
Sorry, do you?
Orphans. The second one.
What do you want to do?
Orphan containers. Do we call those, if we run some containers using Docker run, the container name?
Yes.
Do we call it as an orphan containers? Because it
Or often, am I missing here?
orphan.
Orphan. Yes, it would become an orphan. Yes, that's right. Yes. Yeah, that's a good way of describing it, and I've heard that terminology before. Okay. And I've missed off one here. I needed to detach. There we go. That's what I meant to write. Okay. So basically, those are the two options you want. It's possible to do it without either option. If you do it without either option, you just get lots and lots and lots of containers accumulating, yes, which is a bit messy. Yeah. So really, you want this one just to do something, or you want this one because you're bringing up a container and you want it to act as a server. That's the idea. Okay. Yeah. I kind of more to the point, I guess, if you do it with this one, with this gives you back prompt. Yeah, the minus detach gives you back prompt. If you do it without the detach, yeah, you're still not doing the --rm, okay, but it's synchronous, so you don't get back the prompt. Okay? Unless the command gives it back to you. Just getting a bit involved. So I think the simplest thing is just to come back to these two options. A really good place to start if you're learning Docker is to consistently try and remember to use one of those two options when you're doing the Docker run. Yeah? And again, like I said, I wouldn't, unless you're deliberately doing it to try and learn it, which is a good idea, I wouldn't write these commands out every single time, type these commands every single time, and put them inside a script, yeah? So that you don't have to remember them, and so that they're repeatable. Really important that they're repeatable. If you type the same things you did last time, you made a very slight difference, and now it makes a difference, okay? The only way you can be sure that what we did before is the same as what you're doing now, is basically if you're not involved, because you're a human being, you can make mistakes, right? Okay, so done that, done that, done that, done that. Yeah, there's a that will get you a hell of a long way. That if you actually wanted to do this, to write your own mini web server, the only other thing you really have to look into is how to expose the port. That's pretty much the only other thing you have to look into. Okay? Yeah, of course. Yes.
When we are building, we are copying Docker
No, not really. We're building an image. Yeah.
We are doing.
Yeah.
After doing the changes in local,
Right.
the image will be updated.
Correct.
So every day the inserts, the whatever I have is get updated.
If there's a copy. If you do a build, and the build looks at the Docker file, one of the commands in the Docker file is to copy these files from the local in, and then the copy goes in. Yes.
Now we are using
CP, yeah.
the same file again.
You could do, absolutely, yes. It's a good point. Yeah. If you do Docker build, make an image, you do Docker run to create a container from that image, yeah? As you've seen, you can do Docker CP. Yeah? So you might have a fault inside that container. It's not doing quite what you thought it was doing, right? And you think, oh, I know how I can fix this. I'll make a fix on this file here, and then I'll Docker CP the fix in. Bad idea. Really bad idea, okay? The idea is we're trying to build a pipeline. Yeah? We've got a way of taking the source, making an image from it, no human intervention, spinning a container from that, as many containers as we like, okay, and then doing what we like with those containers. So if we just happen to have made a mistake, and we've got an image, and there's a container being built from that image, and there's a fault with that particular container, but that container is running, and it's serving traffic coming in from our users, you know, that's actually doing work, real work. It's a bad idea to try and fix the problem with that, because the likelihood is you're actually going to make a worse problem, right? Modern way is no, as often as you can, you leave it running, and you try and make a fix with a second image, with a different SHA, and then you create a second container, and you see if that one's working properly, and if it is, you start to divert traffic away from the slightly faulty one into the new one. Okay? This is called immutable structure. The idea is you don't change something that you've built, you just build something new. And it's time has come. You need two things for this to happen. What do you need for that approach to happen? It's a great approach. The first thing is you need to be able to build stuff fast. If you're doing it in a PM, forget it, okay? But Docker's fast enough that you can do it, which is why people are doing it, okay? The second thing is you need a hell of a lot of disk space, okay? Because every time you do this Docker build, you get a brand new copy, right? So if you've got a pipeline and 100 developers working on something, and they're doing 100 commits a day, you've got 100 images being built a day. Okay, this stuff adds up pretty damn quick. But these days, this space is so cheap, it's not an issue. Okay? That's why the modern way that developers are building software is they don't muck around with existing running applications. They just build a new application until they're happy that this one's working, and then they divert to that one. And when everyone's diverted to the new one, and they're totally happy that the old one has not received any new traffic for half an hour, let's say, then they kill it. But it was dead anyway, it was doing nothing, right?
So, what is the difference between Docker and the Kubernetes?
What's the difference between Docker and Kubernetes? Kubernetes is basically an orchestration framework. And this is, again, you may or may not get to this in your careers, I don't know, but what have we been building? The answer is we've been building one image. And when we split a container from that one image, we get one container, right? But supposing you actually have split your architecture into 3 parts. This is what I did with Cyberdojo. It's actually in 8 parts, okay? So it's not, you can imagine building the software and it's 8 times as big as it would be if you split it into 8 parts, right? Yeah, why would you build it in 8 separate parts and each part has its own image, yeah? With its own repo, in fact, its own GitHub repository. Why would you have it split into 8 parts rather than having just one repository with everything? Any ideas why 8 might be better than 1? There's one overridingly good reason. Yeah? And that is, helps avoid conflict. Yeah? If I've got one repository and all of us are working on this repository at the same time, it's inevitable we're going to get conflicts because we're going to try and make the same change to the same thing at the same time. It's all just going to get horrible and messy, okay? If we split it into 8 pretty separate parts that communicate through some protocol, HTTP, almost inevitably, okay? Then you're working on one part, you're working on another part, you're on another part, we're all much more separated. Okay, and it's much less likely we're going to tread on each other's toes, but basically we can work faster. The bottom line is we can work faster. Okay? Yeah? So it's a really good thing. If we can split it into 8 parts, we've got 8 separate teams that can work in parallel. Right? We still have to make sure that they communicate properly, so that each individual bit of the application talks to the other bits correctly. Okay? But genuinely we can go much faster. But we've introduced a problem. Because when we've got one application and we spin it up, it doesn't have to talk to the other 8 bits. There aren't another 8 bits. It's just one application. It can talk to itself as it's itself, okay? If you split it into 8 parts, and each part creates an image, and each image starts a container, you have to arrange for all of these containers to be able to talk to each other. Yes? You just do. And again, that's not particularly difficult, but that needs to happen, okay? So imagine the same situation. We've got our application that's up and running, serving clients from the internet. It's an actual business making money. And there's 100, let's say 100 containers, all talking to each other, built with 100 separate teams, okay? Making money, yeah? Everything looking good. But then we have to do an update. We adopt the same idea, yeah? We don't change this one. We just make 100 new images, and then we bring up 100 containers. We make sure they talk to each other correctly. We try and divert the traffic to the new set of containers, 100 of them all talk to each other. One of them probably being Nginx or some kind of server at the front end. Okay. Everything's been, there's no battery running, and everything's been converted, you shut down the other 100. Now, I don't know about you, but I wouldn't want the job of orchestrating all of that. To bring up 100, make sure they're talking to each other correctly. That would be a nightmare, okay? Plus, think about another problem. When you bring up a whole new set of containers and they have to talk to each other, how do they do that? Because these now have different IP addresses than they had when they came up the first time. Okay? It could be a really difficult problem if you were trying to do it yourself. So, Kubernetes is a technology, an orchestration technology, that attempts to basically do all of this orchestration when you're doing a proper, fully blown deployment of potentially quite large amounts of stuff. Okay? And it does a lot more besides that too. It's really, really fantastically powerful. It is quite complicated. It does take quite a bit of effort to get into that. But if you've only got relatively simple applications like Cyberdojo, you don't need Kubernetes.
This is a read article.
Right.
So the title of the article is Docker is dead.
Docker is dead.
Yeah.
Well, it is true in the sense that if you know Kubernetes, you've pushed everything down a level of abstraction, and you're just working at a higher level of abstraction, the Kubernetes declaration. Yeah, you're saying in your Kubernetes configuration files, I've got these 100 services, and I want you to start containers from those 100 images, and the names of the services are such and such, and okay, when you bring them up, the IP addresses are going to be different each time, but hey, You take care of that. You just arrange for the name that I'm using to be what's used, and underneath it'll go through. It does all that for you. Okay?
Which one you prefer to go? For example, these are going to be engineers.
Right.
So which one you prefer? Docker or Kubernetes?
I think you should start with Docker. I think, yeah, I would start with Docker. Get a little bit of Docker at your fingertips. But if you really want to do Kubernetes, then do Kubernetes. but a little bit of Docker before you start Kubernetes is certainly going to help, no question about that. Yeah. It's also quite a moving target at the moment. Kubernetes isn't quite stable yet. Yeah.
After 1 or 2 years, even Cyberdojo could be moved to Kubernetes?
It's possible. It depends whether it gets popular.
We are already popular.
Yeah, but what I mean big time popular. Because again, this is a good question. One of the things that Kubernetes does is auto-scaling. Yeah? So imagine you've got a container that's serving your traffic. Okay, and then for some reason you get some kind of internet hit, and suddenly your business is incredibly popular. Yeah? And all of these big young people around the world are flooding into your site because they want to buy the latest useless gadget or whatever it is, okay? Right? But you haven't built your site to cope with all this demand, and your site falls over. If you think about it, it's tragic. This was the moment you needed the site to be at the most, because you had the most traffic coming in. You'd have made so much money if that site could have stayed up. If you didn't build it to stay up and it fell over, okay? With Kubernetes, again, if you arrange it correctly, then what happens is it automatically scales. Okay? As the increased demand comes in, Kubernetes says, look at heck, there's a lot of demand coming in now, and it sees the CPU of this one going up and up and up, and before it gets to the point where it would have died, it creates a new container. And it knows this new container is an exact duplicate of the first one, because it makes it from the same image, right? Yeah. Now, half the traffic comes into this one, and half the traffic comes into this one. You've done nothing. You set this up beforehand, months ago, in your Kubernetes config file, okay? Yeah? And nothing was popular for ages. It was just sat there with one little server. Now it's 2, okay? And then it becomes more popular. The CPU of both of those goes up, and it says, blimey, now you've got 4. Still not enough. You're still getting coming in. Now it's 8. Now it's 16. Okay? But it's up. And each one of those is making money. Okay? But then the demand dies down after 2 days, let's say. Yeah? And now it's 8. Still quite a lot of demand, but it's dying down. Now it's 4. Now it's 2. And maybe it settles at 2. We've got more than we had before. Right? We've actually been successful, word of mouth. We're kind of moving on at 2. And this is the kind of thing Kubernetes can do for you. Yeah, amazing. Really, really amazing. This is the kind of thing I mean about pushing down the level of abstraction. Right? Which is why more and more people do it. But you do have to learn the technology. And if you learn the technology, Kubernetes technology, and make your site use that technology in the hope that you're going to need that extra demand, that it'll scale when the demand comes in. If you never need the demand, it's kind of a shame that you put all that effort in. Okay? From a company point of view, it's never a shame from an individual point of view. If you know Kubernetes, you've got a really good chance of getting a good job with a high paid salary. More and more these days, I would say that's definite. Plus, if you know Kubernetes, you want to put it on the CV for sure. Okay? DevOps, yeah, they kind of call it DevOps, but it's blurring. The lines between DevOps and between Dev and Ops is blurring. No question about it. I see more and more developers who do the Dev and the Ops. There's definitely demand for DevOps engineers, yes. But how do you do the Ops? The answer is, as you see more and more, you don't do things manually. You script it. And you need programming skills to do proper scripting. Okay, so that's why I said the lines are blurring. I know plenty of people, quite a few of the instructors on the Citigroup stuff in Chennai. Well, we're in Chennai, there's 2 instructors in Singapore,
There's 2 in London, 2 in Dublin, there's 2 in New York, and I'm forgetting there's 2 somewhere else, it doesn't matter, okay? A lot of them are about to do their own DevOps, set their own infrastructure up. Yeah, so. Like I said, the lines are blurring. There's some really good sites on the internet where you can, if you want to learn this stuff, you can learn it in a sort of playground. Yeah, you can literally go to a website and it looks like you've got a terminal in front of you, and you can type stuff in that terminal, and you've already got Docker. It's going, isn't it? Is this going? And you've already got Docker installed, basically. Okay. In a virtual environment. Same for Kubernetes. Yeah. Completely for free. You just try it out, experiment, learn stuff. Yeah. I hold it like this, it seems to be okay. Yeah? Yeah, thanks. And now I've said that, I've realized what an idiot with me that I've been. What an idiot I have been. Well, maybe I'm being slightly unfair on myself, because those of you who have successfully installed Docker, you can now try Docker on your machines, and you don't need an internet connection to do that. You've got Docker on your machines, okay? But what we could have done is we could have tried, what's it called again? Play with Docker? Yes, PWD. We could have tried play with Docker. So you literally click start. Sometimes the demand is too high. You create a new instance, and here we are. We're in the terminal, and look, we've got Docker. Yeah. So that's the way you can try Docker out. Except anything you do will be lost. You can make a command. You can make a Docker file there. Yeah. You can build on the Docker file. You can run the Docker file. You can do loads and loads and loads of stuff. But the chances are, unless you are clever, the images you create are going to be lost when you shut the session down. Okay. What do you think of that? Now, there's similar sites for Kubernetes. This one just is just for Docker, though. I'm pretty sure Kubernetes is not here. That's called Play with Docker. Should have tried that. Sorry about that. If you might have to create an account thinking about it, because this is on. I'm pretty sure this is hosted by Docker now. Yes, sponsored by Docker. So if you go to you Google for this and you get to the same page, you might find you have to log in basically first. Okay. Play with Docker. Why didn't I think of that earlier? It's my shell. Excuse me. How many at a time? 10 minutes, okay. So what do you want to do for 10 minutes? Which ones?
removing the image, that's a good idea, yes. So, I'm back at my terminal. You could do this in the Play for Docker window if you want. The Play with Docker window in your browser. They would be absolutely the same. It's perfectly fine. In fact, let me do that. Why not? Just for the sake of it, let me do that. You don't have to do this. You can do it wherever you like. Or maybe I'm pushing my luck because it seems to be struggling to connect to the internet for a minute. Yeah, let's abandon that idea. Let's just do it locally. Here we go. So we've got. I can get rid of this file here. We don't need that file anymore. Okay. So let's go Docker run -1 detach, and let's make a container from kgisl. Let's give it a name. I'll call mine JJ, and let's see that running. Okay? So I've created a running container called JJ. It's built as a container from the kgisl image, and I've detached it so it's running separately, and I get my prompt back. Okay? And the running container, as well as having a name, JJ, also has the char. That's the char that we talked about earlier. Okay? So it's BFF33, etc., etc. And so now, if I do either Docker PS -a, which is kind of the old-fashioned way of listing your containers, when thinking about them as processes, PS is a command in Linux to list processes. The modern way would be container ls, which is much better. Then it's not there. Interesting. Why is it not there? I may have left a command in, of course. That would have an effect. Whoopsie. So let's just close that one and have a look. That's what I've got as my command. Is that Docker file? Let's have a look. Yes. Yeah, that's interesting. That is interesting. Docker PS -a. Now we see it. Okay, so it is there. I wasn't losing my mind. We have created a container, and the name of that container is JJ, and the hash is still the hash that we saw when we added commands. Okay, it's just I did Docker PS -a to see that, and the other command I did was Docker container ls, not ls -a. So it's my bad. You need the -a to say, I want to see all the images. And there it is again. Okay? So that was the command I used to create it. And then you can either do Docker PS -a or Docker container ls -a. Okay, so now how do we kill it? How can we remove this container? Two ways. We can either remove it by naming the name of the container, or we can remove it by naming the char of the container. Those are pretty much your choices. Yeah. So let's do Docker rm JJ. Let's remember to add the false this time. Yeah. False it to die. Gone. It's not there anymore. Okay. If I do Docker PS -a, it's not there anymore. Let's build another one again. So I built another one. It's got the same name, but it's a new container. It's got a different hash, a different char. So if I do clear Docker PS -a again, there we go. New container called JJ, same name, but it's new. It's got a different char, as you can see on the left, container ID. So this time we can remove it using the char. Yeah, it's still gone. If I do a clear. And then Docker PS is gone. So Docker RM. And actually, this is a nice, probably perhaps a nice thing to finish up with. Very common beginner's mistake is instead of writing Docker RM, instead of writing Docker RM stuff, they write Docker RMI stuff. Yeah? I certainly get confused by this all the time, because this is a valid command. You can do Docker RMI, and that means remove the image. Remove the image. This one RM is for removing the container. This one is for removing the image. Yes? So, if we come back to our prompt here, and we do Docker images, or Docker image ls, I've got a whole bunch of images here, because I've got some stuff I've been working on, which is to do with a new project called Assessor. I'm just trying to see if there's anything I can delete here. What was the one we built? Where's Hello World? Hello World should be there somewhere. I can't be bothered to get through all of that. Let's just pipe it into grep and look for hello. Yes, so we've got an image. Yeah, we've got an image called Hello World, which is the one we ran as the very first command, yes? So if I now go Docker RM Hello World, it will fail. It will say, no. There is no container called Hello World, because the thing that's called Hello World is the image. The image, yeah? You create containers from the image. So it says, no, can't do that. So if you do Docker RMI, we now have another problem. And the problem is you can't remove an image if there are containers running live from that image. Yeah? Because there's obviously a dependency. Yes? So in this case, there's only one container, I think, which is this one. It doesn't have a name, it only has a char. Yeah? So if we genuinely wanted to actually really brute force remove this, we could say rm-f, and then we would take the container, and now the container's gone, and so we can come back and do the RMI of hello world, and now we've got a different one. So there must have been two. So let's try getting rid of that one too. Let's go again, and now it's worked. Yeah? There's stuff happening here, and we could talk about that if we had more time, because it turns out, as I said, this idea of building images could potentially be very, very costly in terms of disk space. But there's a layering technology that Docker uses, and if you want to learn about this, the technology is it's called a union file system. So there's a union file system, and we can see what we think of as one image, yeah, is actually a number of layers unioned on top of each other. Okay, this was the bottom image. Someone created an image on top of that with a from, and then someone created another image on top of that with another from. Yeah, and they layer on top of each other in a very, very efficient way. You're still using a lot of disk space, a lot, but it is more efficient than you might otherwise imagine. Okay, and again, that's really good stuff to know. What's happening. It also affects the caching, which is again really valuable stuff to know, because it turns out, if we just for a moment come back to the file that we were looking at, the actual file I was looking at for the group of students in Chennai, this is my Docker file here. Let's actually fix that problem there, because I didn't need to put that space in. You see I've got two copy commands. I've got a copy on line 4 and a copy on line 6. Yeah? It turns out doing it that way massively better than if I did the alternative, which would be less lines of code, one less line of code, and arguably a little bit simpler, but this version would be much slower than this version, and it's because of the caching. Okay, So again, I'm not going to go into a lot of detail on this, but the crucial point is this npm install, in this case, is running after all the files have been copied. And the assumption is you've made some change when you're rebuilding, and so the cache can't work in this case when it gets to the npm install, because the npm install is running after a change has happened compared to the last time. Whereas if you look at this version, we're copying this package file, just this file, that contains the JSON with dependencies, that's all npm needs, that's the slow bit, the npm install is the slow bit, and so as long as that hasn't changed, the cache will work for the npm install, and that line there will actually have to run, but that's very, very fast. Okay? So there are definite skills involved in arranging the particular lines of your Docker file, knowing about the caching that's going on because of the union file system. Okay? Again, this is all standard stuff. It's not like I've found magic out. It's all stuff on the internet that you can find very easily if you just search for it. Okay? So I've got to remember I've got to make a git commit for that because that's changed now. Okay, so let's do a cleanup. Here we go. I'm on Docker PS, and I actually don't have any other stuff left over. That's what I started with, so I'm going to leave that there. Okay. And I guess we're out of time. Yeah, we're out of time. Okay. Get rid of this.